Well, okay.
Good afternoon. So I'm going to highlight VisualSim interface to any prototyping system. By prototyping system, I mean FPGA systems. So you can use them for system level simulation and performance measurements. Okay. So you can use VisualSim to generate the system scenarios, and you can send it to the SoC or your system on the FPGA platform, run it on the FPGA, and take results back to VisualSim so it can show the performance for that particular scenario that you ran on the FPGA. So for our demo, we have taken a Zynq platform from Xilinx. The Zynq platform has a dual-core ARM processor plus the programmable FPGA interface. So the dual-core ARM talks to the peripherals through the AMBA interconnect, basically the AXI interconnect, and we have used one of the gigabit Ethernet ports on the Zybo board. So we have used a Zybo FPGA platform to build this interface between VisualSim and the FPGA or the Xilinx FPGA. So the overview of the VisualSim interface itself, we use the Ethernet port and the ARM processor to interface to VisualSim. We use the UDP protocol for communication to the Ethernet port. We've used UDP because the process itself is a very simple process of communication between the host PC, which is running the VisualSim, and the stack itself is very small. So you can actually put it to or reuse it with your operating system or a small embedded OS that you're going to run on your board. So the ARM processor on the Zynq platform or Zynq FPGA runs a small UDP stack to communicate with VisualSim. And essentially, as I mentioned before, you can use it for with any other prototyping board on the network. So you could use this board stack with a board sitting with another with a customer, or with the customer can use it remotely as well, as long as they can put it on the network. Okay.
Okay.
So VisualSim itself communicates through the UDP protocol, and any information that is communicated to and from the prototyping board, you can actually pass any information that you want from VisualSim to the FPGA. So you could send packets, you can send just raw data that you want the FPGA to use. So what the processor or the interface itself will do is it will take this UDP and take the data that you're sending and then give it to the FPGA in whatever format that you want. So the processor on the prototyping board will talk to the programming logic to the AXI interface, or the processor can also put it into the memory and ask the FPGA system to take the information off the memory and process the information. So in case you want to do some image processing or big chunks of data, you can use this interface to write the image into the memory on the FPGA board and then ask the FPGA system to process that information. So we have listed some example applications here. So you can generate and run system level scenarios. That's what VisualSim does best. So it can generate system level scenarios from your system definition. Then you can use this to transfer the data from VisualSim to the FPGA through the VisualSim interface, and you can do the analysis on or the computation on the FPGA and send back the information to VisualSim so it can process and display the information itself in a user readable format. You can run performance simulations on the actual hardware system where you generate complex scenarios and then you send it to the hardware, and when you run it on the hardware and collect back information, you're going to know where are the bottlenecks in the FPGA system itself. So you know that there are performance bottlenecks in your hardware, so you can optimize for these performance bottlenecks on the hardware before you actually build a chip with that. The other application is generally running power or low power scenarios on simulation is very time consuming, and you may not always be able to exercise all power scenarios. So with this VisualSim interface, you could generate power scenarios where you create traffic only on certain interfaces, and on certain interfaces you do not generate any transaction, so it goes to a low power mode, and then you bring it back to a powered state and then see how the system behaves. Okay?
Okay.
Any questions, please, before I show you the actual system working?
Ah, そうですね。Please continue.
Okay, so I'm presenting here a VisualSim interface or a model that we have used to demonstrate the interface between the FPGA and VisualSim. So what we are essentially doing is we are generating Ethernet packets and sending it to the board, and then we are listening to the board or the Ethernet port and getting back the information, and we are displaying that information here. I'm just bringing up So this is the Vivado screen. I have implementation for the FPGA itself, which basically runs the Ethernet core plus the ARM processor.
Okay.
And I have my UDP stack here, which will be running the UDP code. So I am programming the FPGA now with the bit stream. And I'm connecting the terminal to the FPGA itself. And now I run the code. So now you can see that the board is running the UDP stack, and it is waiting for data from the VisualSim interface. So here I'm going to start the VisualSim interface. I'm going to start the VisualSim interface, and VisualSim is sending out these packets here. So VisualSim has sent out all these packets on the Ethernet port. It has sent these data. Okay. So what the FPGA essentially does is it is receiving the data, it is parsing the information, it is identifying the source address, the destination address, and the payload information. And while it is returning back the data, the FPGA is changing the data content with this. It's basically adding very simple information to this data packet, and it is sent back through the UDP port back to VisualSim.
Oh, I see.
And you can see just a second, please. So this is the data that is coming back from the FPGA, and this is the data that was sent on the interface.
Okay.
We have also put a latency measurement window here. So this just gives you the latency on how quickly the data comes back. It is just an incremental increase because we are adding the previous time to this. So the total time that was spent was about 11 seconds. And you can see that the time itself is very short. The interface returns back almost immediately with the data. So the overhead on the interface is very less. So you can, whatever latency is going to happen is on the FPGA platform itself. So you can know that how much time you're spending on the FPGA. Any questions, please?
ABC です。多分データをどっかに送って、アドレスから返ってくる時間を測ってるんですよ、多分。元々のライトのところが多分 イーサネット経由で多分向こうに繋がって、何か書いて、リードで戻ってきたやつをレシーブして、その時間をずっとレシートして測ってるんだと思うんですけど、横時間あるんじゃないですか。聞いてみたらどうですか。